So basically, Safrina, in common system, there nomenclature की बात होती है, तो we'll just talk about the common system, how to name the compound, organic compound in common system, and how to name in IUPAC system, right? So in common system, we just add the word halide, okay? After alkyl group, first हम क्या लिखते हैं? Alkyl group, and after alkyl group, we just write down the name halide. If it is fluorine, so we just write fluoride. If it is chlorine, so we just write chloride, right? So accordingly, just write down the name. It's about the common system. Suppose, for example, this is a structure CH3, CH2, CH2, Br. Now, which halide is this? Bromine is attached, right? Bromine is attached. Now, what is the parent chain? This is the parent chain, right? The longest carbon chain is a parent chain. So this is a parent chain. 1, 2, 3, right? So 3 carbon chain. So 3 carbon chain ko we called it as a, what we named it as, Safrina? For 3 carbon chain, क्या use करते हैं हम? Propane, yeah. And this is your alkyl group, right? So basically common name में हम क्या लिखते हैं? We just write alkyl group name first, basically propyl, and after propyl we just write down the halide word, right? We just write down the halide word. So this is your propyl bromide, yeah? That's a common name, propyl bromide. Write down. Yeah, you have to make the notes along with me also. First try to understand the concept, उसके बाद आपको notes बनाने. And this straight chain is this is a normal structure, right? So for normal we write N propyl bromide, N propyl bromide. And see, in IUPAC nomenclature, how to name the compound. So alkyl halides are named as halo substituted hydrocarbon. हम halogen को पहले लिखते हैं as a prefix. Okay, so suppose this is a bromine, right? So bromine word is there. So we just write prefix for the bromine, bromo. If it is chlorine, so we just write chloro, okay, iodo, and so on. So in IUPAC name, how to name this? So it's at the first position, first carbon, the bromine is attached, halogen is attached, right? So we just write one bromo propane, one bromo propane. Got my point, Safrina? Understand? Yeah. Okay. Try to name this one. Second one. So this is the parent chain, longest chain, right? So how to number this? 1, 2, and 3. This is your third carbon. 3 carbon chain ke liye we called it as a propane, right? So what will be the IUPAC name? The propane is the parent chain. Yes. Yes, Afrina?
No,
Who called me, ma'am?
no, ma'am, I understood.
Okay. Yeah, so its IUPAC is propane. And what about the chlorine group? So chlorine is attached to the second carbon, right? So we just named it as a 2-chloropropane. That's the IUPAC nomenclature. Yeah? Okay. And what about the
Yes, ma'am.
common name? What about the common name? So common name कैसे लिखेंगे हम? So after after the alkyl group, we just write down the chloride or halide. Any halide name हम क्या लिखते हैं common name में? At last, as a suffix. So this is a chlorine, right? So for chlorine, we just write down chloride, chloride. And now see, this is the chlorine is attached to the second carbon position, right? So this type of a structure is known as iso. This is your iso type of a structure, right? So we call the common name for this is your iso. And how many carbons? So propyl, isopropyl chloride, isopropyl chloride. Here, third one,
Yes.
just try to name the third compound.
One.
Yeah, it's an IUPAC name, right? One,
One chloropropane.
are you sure?
One
And what about this?
chloro. Two.
One chloro, two
Two
ethyl,
ethyl.
methyl, right? One methyl. This is your CH3 group. And for CH3 group, we just I laga methyl. So one chloro, two methyl, and it's propane. Yeah. So what is the common name for this? Again, this is your iso type of structure, right? So it's a iso. When we write down the iso word, when you use the iso, so हम ये सारे कार्बन्स को लेते हैं, मीन्स 1, 2, 3 and 4 कार्बन्स. how many total कार्बन्स का हम लिखते हैं, right? So total carbon is 1, 2, 3, 4. So in common name, first write down the parent. This is your, we just write on the root word. What is the root word for the common name? At last, we just write on the halide word. So it's a chlorine. So we just write chloride. Chloride for chlorine. Now this is the iso. Again, the iso structure. So 1, 2, 3, 4. 4 carbons are there. And for 4 carbons, we just write, we just use but word, right? So it's isobutyl chloride. Third structure, common name is isobutyl chloride. Most important thing to write down the IUPAC nomenclature, because in your board exams, IUPAC nomenclature came. They ask you what is the IUPAC nomenclature of this. Write down the name of this according to the IUPAC. So that's very important. Is it okay?
Yes, ma'am.
Now tell me this question answer. Which one of the following halides contain this bond when the halogen group is attached to sp2 hydrazed carbon? I think we have discussed in the previous class. Option A, allyl halide. Option B, alkyl halide. C is your benzyl halide. And the fourth one is your vinyl halide.
Benzyl.
Benzyl, are you sure? See, I have discussed it with you. See, if you, so we have discussed in the, yeah, monohaloalkenes. See, monohaloalkenes are basically are of two types. First one, when the halogen group is attached to the sp3 hybridized carbon. And the second one is your when the halogen group is attached to the sp2 hybridized carbon. Right? And इसमें हमने पढ़ा था, in the sp3 hybridized carbon, there are three types: alkyl halide, allyl halide, and the benzyl halide. You said benzyl halide, right? So benzyl halide is wrong, bache, because in benzyl halide, the halogen group first attached to the sp3 hybridized carbon, and then this sp3 hybridized carbon is attached to the benzene ring, right? So this is a benzylic type, right? So correct option correct option will be the fourth option, vinylic halide. In vinylic halide, what happens? The sp, yeah, in vinylic type of halide, basically the halogen group is attached to the sp2 hybridized carbon, directly to the sp2 hybridized carbon. So that's why vinylic halide is the correct option. Yeah, all the allyl halide, and benzyl halide, in all the three types, the alkyl group is attached to the sp3 hybridized carbon, not to the sp2 hybridized carbon. Yeah, so just remember this. Yeah, Safrina, try to name this question. First, try to find the parent chain. This will be the parent chain. Now, if you want to start the numbering from the right side, तो राइट साइड से अगर आप स्टार्ट करते हो तो दिस विल बी 1 2 3, राइट. मींस वेयर आर द सब्स्टिट्यूशंस आर ऑन द सेकंड पोजीशंस पे आपका methyl group is attached and the bromine group is again attached, 2 2, and on the third position, third carbon, there is a substitution, means unsaturation is there, carbon carbon double bond, right? So 2 comma 2 comma 3. But when you start the numbering from here, so it will be 1 2 3 and 4. So obviously 2 पे है and 4 पे है, so obviously we will not consider that. We have to number as such a way so that the substituent will get the smallest number, right? A smallest position उसे मिलनी चाहिए, तो 2 2 3. So what will be the name of this? Let's try to name this according to the alphabetically order. So 2 bromo.
Should you consider 3 also?
Yeah, we will consider 3 also.
No, like
Yeah,
on 3 is
no,
attached to a different carbon, right? So
we have to हमें ये show करना पड़ेगा that there is a double bond on the third position. How we will get to know where the double bond is present, right? So we will write down the name. जब हम name लिखेंगे तो we will also assign the position to that card. Okay, so first what will be the name? 2 bromo, right? So bromine is there, second position pe there is a bromine and there is a methyl group, and we know that B comes first then M, so we will start from the naming from 2 bromo, then 2 methyl, and what are, how many carbons are there? 1 2 3 4 and 5. 5 carbons are there total. Parent chain mein how many carbons? 5 carbons. So for 5 we just use pent, right? Pent. Now there is a, on the third position there is a double bond, so we will write pent 3 in, right? Pent 3 in means the pent shows that there is a carbon of 5, the parent chain is of 5 carbon, right? And 3, it tells that on the third position, third carbon, there is a double bond, 3 in, and yeah, so that's it. 2 bromo, 2 methyl, pent, 3 in, en. That's it. That's the name of this compound. Got my point?
yes, ma'am.
Any doubt in this? Now see the nature of CX bond. Okay, because we are talking about the haloalkenes, so we will discuss that what is the nature between the carbon and the halogen atom. right? What is the nature of this bond between the carbon and the halogen atom? What is the nature? Okay, so see, carbon and hydrogen means alkyl group of carbon. We know that RX. What is RX? So RX is your haloalkane. Haloalkane, right? So RX. So if we know that in alkyl group carbon is present, so we are talking about the CX bond. The carbon which is present, carbon of the alkyl group and and your halogen के बीच में जो the bond है, we are talking about that bond. Now we know that halogen is more electronegative than carbon, right? Halogens like fluorine, chlorine, bromine, iodine, these are more electronegative than other elements, okay, than carbon. So in this bond, carbon and halogen bond, halogen could be pure either fluorine, chlorine, bromine, and iodine, right? So between these bond, in this bond, when this bond will break, what will happen due to the difference between the electron negativity, right? Because carbon is basically electropositive element, and between the C and X, the X is most electronegative. X is more electronegative. So obviously, जब ये bond break होगा, so this will acquire partial negative charge. Partial negative. X पे क्या आएगा? Negative charge, partial negative charge. And on the carbon, there will be a partial positive charge. Right? Partial को मैं delta से show कर रही हूँ. Partial positive and partial negative charge. Is it clear? Why this happens? Due to the greater electronegativity of halogen atom. The halogen atom in carbon and X bond, CX bond, acquires partial negative character, negative charge, and carbon acquires partial positive charge. Clear? Okay, Safrina?
Yes.
Next is your
Yes, ma'am.
isomers. You can write down this. Write down this point, nature of CX bond, and this point, due to the electronegativity, greater electronegativity of halogen atom, it will acquire partial negative charge and partial positive charge on the carbon atom. Just write it down. And can I scroll down?
Yes, ma'am.
Okay. Now let's talk about the isomers of haloalkane. Okay. So isomers are basically those structures which have a same molecular formula but the different structure formula. Right? Isomers क्या होते हैं? They have the same molecular formula will be the same, but the structure formula is different. So that's the isomers. So basically, there are two types of isomers of haloalkane. Chain isomers, which differs in parent chain length, right? Chain isomers are basically, they are differs in parent chain length. जो parent का chain length होगा, so that isomers have different chain length. Either it could be smaller right? Obviously, the small hoga when you compare the parent chain. So, and the second one is your positional isomers. Now, what is positional isomers? So, they differs in position of halogen atom. Halogen atom का position different होगा. Okay, so that's the positional isomers. Now, let's discuss it with using the examples or questions. You can say this question is given in your NCRT book. Question is, draw the structures of all the 8 structural isomers that have the molecular formula C5H11Br and name each isomer according to the IUPAC nomenclature, IUPAC system, and classify them as primary, secondary, or tertiary bromide. Yeah, question, understand the question? Yeah, so we have to draw the structure of all the 8 isomers, right, of molecular formula C5H11 C5H11Br. Yeah. So the molecular formula is C5H11Br. Now we have to draw all the structural isomers. Now I will teach you how to draw the structural isomers. First, always try to make the very normal type of a structure, normal structure. So carbon 5 carbon. So one carbon, 2 carbon, 3 carbon, 4 carbon, and 5 carbon. Okay, this is a 5 carbon chain. Is it clear? So basically this corners, this tells us about the number of carbon. 1 carbon, 2, 3, 4, and 5. Now 5 carbon is there. Now 11 carbon. Obviously the hydrogen will be 11. Or simply you can, आप ऐसे बना सकते हो. Suppose this is your CH3, CH2, CH2, 3 carbon, 4 carbon, 5 carbon, 1, 2, 3, 4, 5, and the bromine is attached over here. Yeah, the normal structure, normal chain. Yeah, so that's the one. What is the name of this? One, on the first carbon, there is a bromine group. So you can name it as 1 bromo pentane. 1 bromo pentane. 1, 2, 3, 4, 5. Yeah, is it correct? Now, second isomers, how to draw the structure of the second isomers. Just shift this. Now you can see in the first isomeric form, the bromine is attached to the first carbon, right? Now shift this bromine. This is on the first carbon. अब इसे shift करो, second carbon पे ले जाओ, right? So what will be the structure? So yeah, first पे था. Now the bromine comes to the second carbon. Right? Again, the formula is same. You can see that 1, 2, 3, 4, 5 carbon, 11 hydrogen, and 1 bromine. The molecular formula is same. So this is the isomer. Yeah. Basically, you are shifting the halogen position. In the first isomeric form, you can see the halogen is present on the first carbon. Now, halogen is present on the second carbon. Okay. So basically, यहाँ पे आपका only one. Yeah. 1, 2, 3, 4. Is satisfied. Now just try to name this structure. With the name. Yeah, Safrina, tell me.
2-bromopentane.
Yeah, it's 2 bromo pentane. And can you please classify them as primary, secondary, or tertiary one? Which type of bromide it is?
Tertiary.
Are you sure it's tertiary? I think I have discussed it in the previous class. You have to see the bromine group, right? See the bromine group is
Oh,
at
sorry, second.
yeah, so this carbon and this carbon is further attached to 2 groups. So this is your secondary carbon, right? And this is your primary. primary halide. Okay, again, just quickly do that. Just you have to just shift this bromine. Right. Now just shift this bromine to the third position. Okay, third position पे जब आप shift करोगे तो you will get different structure. You quickly do that. 1, 2, 3, 4, and यहाँ पे third position. This is the bromine. Yeah. 1, 2, 3, 4, 5. Again the C5H11Br. But here the position of this bromine group it changed. Right. Now what is the name of this carbon? This compound. It's 3-bromo pentane. And just tell me the which type of halide it is. Which type of bromide, primary, secondary, tertiary one?
Secondary.
Yeah, very good. It's secondary. Now, see, if I shift this bromine to this position, fourth position, right? अगर मैं fourth पे position पे bromine को shift कर दूं, तो it will be, if I shift this bromine to this, so what will be the name of this? You will start the naming from this 1, 2. So again, it will be 2-bromopentane, which is very similar to this. राइट ये इसकी तरह सेम हो जाएगा राइट तो यू कांट डू दैट बट नाउ द दीज थ्री आर एनफ these three isomers are enough. Now what to do that, because we know that 8 structural isomers exist, because in the question it has been given 8 structural isomers are exist for this molecular formula. Okay, so how to uh, draw all the structure formulas or all the isomers. Now see. Okay. First क्या करना है आपको? First you have to make the strong longest chain. Okay, and then add the bromine atom. Then you have to shift the halogen group. Okay, second carbon position, then third, then fourth, and so on. Okay, so you will get the three isomeric form. Now one more thing you can do. This is all about the pentane. Now you can short the chain. Parent chain को आप short कर दो. It was a pentane. Now just make it butane. Butane. See how to do that. 1, 2, 1, 2, 3, 4. 4 carbon chain. Butane. Okay. 4 carbon chain butane. And suppose the bromine group is attached here. Bromine group is attached here. Right. And what about the one carbon? Because 1, 2, 3, 4, only 4 carbon is there. But according to the molecular formula, how many carbons are there? 5 carbons, right? So you can use that carbon. You can use that carbon as a substituent. आप उसे branching की तरह use कर सकते. Okay, you can use that. Just a second. I can CH3, CH2. This is your CH3. You can draw the structures आप straight draw कर सकते हो. Yeah. See, now check it. Is the molecular formula same? C5H11Br. Right, same. What we are supposed to do, we have just reduced the chain length. Parent chain जो था, that is for of pentane. But we have reduced the pentane to butane. Okay, 4 carbon chain is there. This is your parent chain now. And we just use the another carbon as a substituent. So that's the another isomeric form. Now tell me the name of this and what is which type of halide it is, primary, secondary, or tertiary.
2-bromomethyl butane
2,
and tertiary.
2, 2 bromo, 2 methyl. Yeah,
Butane.
yeah, it's butane. four isomeric forms. Now what we are supposed to do, just shift this bromine group here. Okay, so you will get another carbon, another isomeric form, right? We have shifted this isomeric, this bromine over here. So this is another isomer. And what will be the name of this? So again, it will be 2-bromo, 3-methyl butane. Yeah. Now again, shift this bromine here. You will get the another isomeric form. Okay, another isomeric form. What is the name of this? 1-bromo. And on the third position, there is a methyl group, 3-methyl butane. Yeah. So butane we have done. Now, again, just short the chain, short the parent chain. So it was the butane. Now you can draw it for the propane, right? Only 3 carbon chain. 1, 2, and 3. 1, 2, 3. And here the bromine is attached. Okay, and for the 2 carbon, because the 2 is remaining, 5 carbon is there, right? So we have used 3 carbon. Now the 2 carbon को आप use कर सकते हो as a branching, CH3 and CH3. Okay, आप ऐसे भी draw कर सकते हो, like this is your CH3, C, CH3 here. Again, there is a CH3 group, CH2, and here the bromine. Okay, so that was a Weyer's structure. 1, 2, 3, 4, 5 carbon, 11 hydrogen, and bromine. So all the 8 isomeric structures are there. You can see over here. Yeah. So try to name all the structure and tell me which type of halide it is, primary, secondary, or tertiary. Tell me, Safrina, this last one, this last isomeric form, what is the name of this? Tell me the IUPAC name and what is the degree, primary, secondary, or tertiary, which type of halide it is.
1-bromo, 2,
Yes,
2 methyl propane, and it's tertiary.
1,
Sorry,
2. Yes, 1,
1
2.
1-bromo,
1 bromo. Yeah. 1 bromo,
2, 2 methyl
2, 2 methyl. Only one methyl is there. Two methyls are there,
dimethyl
na? Yeah, so we use dimethyl.
propane.
Yeah, it's propane. And what will be the degree?
Primary.
Are you sure?
Yeah.
Is it primary? मैंने क्या बताया था आपको? You have to check this bromine group is attached to this carbon, right? And to this carbon, how many groups are attached? Yeah,
1.
yeah, it's one. I just checked you whether you are confused or not. Yeah, again one. Very good.
Yeah.
Okay, now you understand the concept, right? So it's again primary one. You have to check only this carbon. This carbon is attached to only one group, which is this carbon. Okay, आपको further इसे नहीं देखना है. इसे देख के sometimes what the students do, sometimes they see this carbon and they just tell that there is a quaternary, right? Which is very wrong. Okay, very good. Yeah, now see. So we have completed the isomeric form. Now let's talk about the methods of preparation, which is very important. Very important methods of preparation of alcohols. Just a sec. Yeah. So see how the haloalkanes are prepared. So haloalkanes are basically prepared by different methods. First method is from the alcohol. Okay, so we will see how from alcohols how we can prepare the haloalkanes. Okay, so see, so alcohols where there are various reagents. From alcohols we can use different reagents. Okay, and with different reagents they will give you a different product, which is your haloalkanes. Sometimes they will give you chloroalkanes, bromoalkanes, and so on. So see, using phosphorus based reagent. Okay, साथ साथ आप लिखते भी जाओ. Using phosphorus based reagent. So this is your ROH, your alcohol. What is ROH? Alcohol. So R is your any alkyl group and OH क्या represent करता है? This is again representing the alcohol group. So using phosphorus based reagent. So when you use PCl3, when you treat this alcohol with PCl3, so you will definitely, it will give you the product RCl, your haloalkane, alkyl halide. Yeah, in this case, you will get the alkyl chloride. So basically, when you are using the phosphorus reagents, so in each and every type you will get the haloalkenes. In haloalkene, see the PCl5. When you treat it with PCl5, so again you will get the RCl. Okay, basically this OH will be removed from here, right? OH यहाँ से निकल जाएगा and you will get Cl. Because chlorine, you know very well, chlorine is most electronegative. There is a negative charge over the chlorine. And on the R पे क्या है? And R पे there is a carbon, right? Carbon यहाँ पे alkyl group में, so this chlorine will attach to that carbon, will attack that carbon of the alkyl group, and you will get the haloalkene. Yeah. So see here, there are some examples. Some examples here. Suppose this is CH3CH2OH. Ethanol. When ethanol को आप treat करो when you are using PCl3, so what will be the product? What you are supposed to do, just remove this OH group, okay, and attach the chlorine over here. That will be your product. The product will be this. Very simple. Correct, Safrina? Okay. Similarly, if we are using PBr3, okay, PBr3. So again, this is your OH group. सिर्फ आपको OH group देखना है, just remove this OH group. So basically OH group is replaced by the halogen atom. So corresponding halogen, if you are using Br over here, so you will replace this OH by Br. If you are using Cl over here, so you will replace this OH by Cl and so on. Okay, so what will be the product? So the product will be bromine over here. Yeah. Tell me the third product. Red phosphorus and I2. And the red phosphorus and I2 is the reagent. So what will be the product? This is a cyclohexanol. Cyclohexanol, cyclic structure, not a hexanol, cyclopentanol.
Instead of OH, I2,
Yeah,
I
yeah, very good. Iodine over here. Okay, just replace this OH group by iodine. That's very simple. Okay, so you have written first preparatory method from alcohol. And in alcohol, first part is using the phosphorus based reagent. Yeah, I done the examples also. Next one, using thionyl chloride, which is very important. Why this is very important, I will let you know. So thionyl chloride is basically SOCl2. SOCl2 is known as thionyl chloride. So when alcohols are treated with thionyl chloride, they just form alkyl chloride. Alkyl chloride, and the byproduct is HCl and SO2. See the reaction. So when you take alcohol and when you treat it with thionyl chloride, SOCl2, in the presence of pyridine, pyridine is a base, right? So यहाँ पे pyridine लेते हैं, we just take the pyridine as a, you can just take it as a catalyst over here, right? So it will give you RCl corresponding alkyl halide, RCl, and the byproducts are HCl and SO2. Now here's a question: why I have been why I said it. This is very important. This preparative method is preferred over all the methods. Why? See, this method, the method of by in which the SOCl2 thionyl chloride is used. So basically, you just get the product in a pure form. Okay, why pure form? Because you can see the HCl and SO2, these are the byproducts, and the byproducts in this case is in the gaseous form. Yeah, तो अगर gaseous form में byproduct है तो they can easily evolved out, right? So the byproduct are in gaseous state, so they can easily evolve out, and you get the product in a pure form. Okay, so further there is no need to of further purification of the product. You just get the product in a pure form because all the byproducts are in gaseous phase, so they can easily evolve out from the reaction. Is it clear? Yeah. So that's why this method is used, or you can preferred above all the methods. Okay. क्वेश्चन भी है यहाँ पे, why thionyl chloride is preferred method of preparation of alkyl halide from alcohols. So why it is preferred method? Because the byproducts here are HCl and SO2 are escapable gases. They can easily escape out. Okay, and we get the pure alkyl halide. Hence, there is no need of purification. There is no need of further purification. So that's why this is a preferable method. Clear? Now write down.
Yes, ma'am.
Yeah. Write down this reason also, note करके आप लिख सकते
Yes.
Okay. Yeah. Another method, another method is from the halogen exchange method. Okay, so the name suggests that halogen exchange means there is a replacement or exchange of halogen. One halogen is being exchanged from the other, right? So the in halogen exchange method, there are three reaction: Finkelstein reaction, your Schwarz reaction, and Hunziker reaction. This is very important. All the name reactions are very important for your exams. So first, write on the heading Finkelstein reaction. Okay, so what is Finkelstein reaction? So basically, in this, alkyl iodides are often prepared. By Finkelstein reaction, we prepare alkyl iodide, right? Alkyl iodide by the reaction of alkyl, either alkyl chloride or bromide with sodium iodide. What is the reagent? We just use the reagent sodium iodide in dry acetone. Yeah, what happens, Safrina? You got disconnected.
No, my network is unstable.
Okay. So Finkelstein reaction, what are the reagent we use? Sodium iodide. Okay. So and in the presence of a dry acetone, we just use the solvent as a dry acetone, right? So just remember this is known as a Finkelstein reaction. So when you react the alkyl chloride or bromide with sodium iodide in the presence of dry acetone, you get the product alkyl iodide. Okay, so basically Finkelstein reaction is the preparative method of your alkyl iodide. Alkyl iodide, just remember that. For example, the reaction is when you take the alkyl halide and their hydro, यहाँ पे क्या होगा? Halide should be your chlorine or either bromine. Okay, either it could be a chlorine or bromine. So alkyl chloride or bromide. And when you treat it with sodium iodide in the presence of acetone, and when you give heat, the product will be formed, which is alkyl iodide. और ये आपका NaX will be evolved out. Yeah, sodium halide. Yeah, if you are taking, suppose there's an example. Okay, so CH3CH2Br. Okay, so when you treat it with sodium iodide, what you're supposed to do, just replace this because this is again a halogen exchange method. Okay, you have to exchange the halogen. यहाँ पे halogen का exchange हो रहा है, right? So bromine has been exchanged from the iodine. Okay, तो यहाँ पे iodine लग जाएगा. You will get the product alkyl iodide and the sodium bromide will be as a byproduct. As a byproduct, sodium iodide is formed. Similarly, third reaction, first example, second example. Okay, cyclopentane. Okay, this is your cyclic structure. Okay, so basically, this chlorine is replaced or exchanged, basically exchanged by this iodine. यहाँ पे iodine चला जाएगा and this chlorine is replaced by this. Okay, so you will get the alkyl iodide. Okay, यहाँ पे आप क्लोरीन को रिमूव करके आयोडीन लगा दोगे and NaCl will be your byproduct. Okay, basically you have to, what you are supposed to do, just exchange the halogen. Exchange the halogen and just remember, keep in mind that in Finkelstein reaction, alkyl iodide is formed. You have to form the iodide as a byproduct, as a product. Clear? Sorry. Safrina, clear? Any doubt?
No, ma'am.
Yeah, no, write down the Finkelstein reaction. Written?
Yes, ma'am.
Done? Okay, Safrina. So, in the next class, next backup, basically, Safrina, listen carefully. So, because you have joined late, okay, and your exams are also coming, so we basically you have to join our batch, C4 batch, okay. And in that batch, I have almost completed this Haloalkenes and Haloarenes chapter, and we are on the topic elimination reaction. Okay, so we are starting the elimination reaction, so you can join our batch from tomorrow. ओके सो बेसिकली वो बैच होता है हमारा ट्यूसडे एंड थर्सडे ओके सो फ्रॉम टुमारो यू यू हैव